Okay, so yeah, if we break this thing up by section here, let's look at the first derivative first. So the first derivative, we've got a boundary at, it's where does it change? It changes from negative to positive at 0, right? So everything for the first derivative, f prime is less than 0 to the left, so it's decreasing. Makes sense, right? It's increasing the entire rest of the time. Oh, you know what? I'm going to give you guys full credit on that one. Because I think what you did, I think, is okay. Oh, no, it's not. Oh, no, it is. It is. You're good. You're good. You're actually, Joseph, yours is good. Yours is good. Yours is good. Okay, so then what about the second derivative? Let's look at the second derivative stuff. Second derivative transitions from negative to positive at -1. Okay, so everything to the left of this should be negative, which means downward concavity. Okay, that makes sense. So here we've got downward concavity and decreasing function. Check. It's positive all the way until we get up to 8, right? So in this region in here, we've got second derivative is positive, so it's concave up on this interval. So let's look at this little spot. It's concave up and decreasing, that's the right shape. Concave up and increasing, that's the right shape. And then, does it ever transition again? It's between, yeah, it does. Okay, so between 8 and 10, the concavity is negative, and then after 10, the concavity is positive, right? So then this section makes sense too. This is going to be increasing concave down, so that's the right shape. And then this is increasing concave up, so that's the right shape. So the only difference you had was you didn't have a horizontal tangent there, but you don't need one. Okay? That didn't have to be a horizontal tangent. Okay, so you're good. So then, let's award points. So,
wait, I have a question.
Yeah.
Okay, so we got to like a quarter of that. Like we got our concaves were right?
Right.
But how do you get the rest of the information? Like we know it's whether it's supposed to go up or down, but like how do you know that it's increasing, but it's concave down, and then it's, you know what I'm saying?
Okay, so you're looking at the overlap of these sections. Here, let's try doing it this way. So if we do, let's do, okay, so where it's increasing, we're going to do a blue shaded region. So the function is increasing every place over there, right? So that means increasing function. Good? Decreasing every place where it's not shaded. Now if we superimpose that with places where it's like, let's say where it's concave up, it's going to be red. So it's concave up. I don't know if this will help or not, but it's oh, it doesn't make purple. That's bad. Oh, that's not going to work. Never mind. That's just going to confuse you. I thought it was going to give me like overlapping colors, but it doesn't.
Oh, wait. So you, since you know that on the left side of 0, it's always decreasing.
Yes.
In this case, and then the
Yeah.
opposite. So even if it's like concave up, it's still decreasing, so it has to go all up,
Right.
and vice versa.
And so, I mean, you can kind of, like you could say, like if we take this section right here, if it's decreasing and concave down, doesn't that have to be, what's that have to look like? That has to look like that, right? And so we know, I mean, you're gonna have to kind of attach these things smoothly, but that's the first shape we get. Here we get decreasing concave up. Doesn't that have to be like that? See what I'm saying? I mean, you know, you have to, so that one's gonna hook up to that one, and we get up to there, right?
Yeah.
See what I'm saying? This next one's gonna be increasing concave up. Well, that's gotta be like that. So then that one's gonna hook up to there. See what I'm saying?
It's the exact same as the positive.
That's right, yeah, exactly, yeah.
I shouldn't see it that way.
Right. And so with a table, And I'm not gonna build a table for this one, but you can see with the table, all you'd have to look for is, it'd be easier to see, because you'd get pluses and minuses looking in these regions between the critical numbers, right? And depending on the orientation of the first, of the F prime row and the F double prime row, there's really only 4 possible things that could happen. And then what's the other one? If we get concave, oh no, we get increasing concave down, yeah, so there's the other possibility. So this one is gonna be like that. That's it, those are the only 4 possibilities you could get from combinations of signs of first and second derivative. And then we just have to stitch those together, so, you know, that point right there is gonna go right there,
Yeah.
right? Okay?
Do we still get partial credit for ours?
Let me look at it again.
No.
Credit for our positive.
I just didn't touch it.
Okay, no, I can't, see the problem?
Yep.
Yep, can't do it.
Start to-
Okay, so, where's my, there we go. Okay, so let's see, team, well, this is we'll make this a 4-pointer. So come on up, teams 3 and 4, yep. You can pick,
What are we, what's the goal here? What are we saying?
It's like
you get 2
Battleship.
random blocks, and then after.
oh, here, let me move this, real quick, I'll move this out of the way.
I'd call C4
The
to
last
see if there's
digit of
score.
the score of that we get, and then the last digit of the score of the other
For our
team.
playoff game.
They line up, and whatever block it
And you
lands
get
on, you get a
fantastic
point.
Like if we win 68 to 47, then wherever the 8 is, when I pull this away, these are random digits. So wherever the 8 lines up with the 4, that would be the winning square. And you win fabulous gifts and prizes for
So
your
it's
group
just,
if
it's
you
kind
win.
of random.
So should we just
So
pick any four?
if in 2 weeks I'm playing games,
Yeah, how many
win
points
by
we
that
get?
number.
We get 4.
Said 4
Say it again.
Wait, what does this happen?
So then if your group owns the grid spot where the last digits line up, your group wins fabulous gifts and prizes.
How many boxes do you get?
4.
So I'll
We're
just
just
do
picking.
We should, so we're trying to,
Yeah,
we're trying to find a number that will
I don't think
our
it
game.
is.
Yeah.
Are we gonna
Color
read?
it.
Chauncey, let's pick numbers that potentially miss shots.
But you guys, see, the thing is, you guys don't know, the digits are randomized at the
So
top.
we just, it's all
Yeah.
random?
Yeah. So it's all
So
random.
it's all chance.
Okay.
I
but
think
it's
we
like
should, I
if
think
the
me and
right
Chauncey
is
don't know what
canceled.
numbers Yeah.
Okay.
So each one of those gives you a 1% chance of you're adding it up. So
Nice.
you now have a 4% chance of winning fabulous gifts and prizes.
Better chance than what I put in for
I know, that's what I said.
Yeah,
We said you got carried.
Understand this problem?
You got
Carry, carry.
Did I help you understand this problem?
Yeah, you really did.
can I help you on that?
Did I? Did I? No, I said, did I help you understand this? Oh, stop recording.
Oh, yeah.
Red man.
Okay.
That's it.
Okay, so what about this now? So let's talk about it. If we know that the function is concave up everywhere except 0, right?
Yes.
Concave up everywhere except 0, and it has a local maximum, what's this thing have to look like? So if this is,
I said that like 3 times.
No, you didn't. You said right next year.
what's it gotta do?
I said C.
It's concave up, right? It's bowl shaped up.
I didn't say C.
It has to do something like this, right?
Yeah.
Does that make sense? Okay, so for that to be a maximum and it to be concave up, it has to look like that. So really, what is the correct derivative here? The correct answer? It's A, yeah. The correct answer is A. If you put, so here's how I'm gonna do this. If you put C, your drawing could have been, you could have had a drawing that looked like this. And I would have, this is one example that would make sense. If you had what we're gonna call a cusp. If it looked like that where you had a vertical tangent line, I would give you credit for C, but really that's only partial credit because it doesn't have to be infinite. An infinite slope doesn't exist, but not all slopes that don't exist are infinite. So I'm going to make this a 4-pointer, and if you got A and a sharp corner, you get all 4 points. If you had the right picture with answer C, you get 3 points. If you had the right picture but the wrong answer, it wasn't A or C, you get 2 points. Make sense?
Yeah.
Okay.
No, that's the point of the